everyone, and welcome back to another fun and exciting day of learning in third grade. We're going to continue our magnet adventure in science, and today we're going to read a book called Magnets, Pulling Together, Pushing Apart. All right, I'm going to read the book out loud to you guys, and then we're going to talk about 3 takeaways from the book. So here we go. Amazing magnets. Let's hold this over here so you can see a little better. Magnets have the amazing power to make things move. When strings pull and lift things, it's easy to see how they work. Magnets seem to make things move by magic. Watch a paperclip scoot to a magnet. The paperclip slides along as if pulled by an invisible string. Magnets pull only on special kinds of metal. Try to move a steel spoon or an iron nail with a magnet. Now try a ball of cotton, a rubber band, or a plastic pen. How do magnets work? Magnets can only pull things that are close enough to them. Put a paperclip far away from a magnet. Slowly move the paperclip closer and closer. How close does it get before it leaps toward the magnet? Magnets can work through a covering if it's thin enough. Lay a sheet of paper over your magnet and place the paperclip on top of the paper, or try putting a piece of plastic wrap on the corner of your shirt and on top of the magnet. What happens to the paperclip now? Dangle an iron nail from the end of a magnet. Now touch a paperclip to the nail. The paperclip sticks to the nail. The nail has become a magnet. When some metal objects touch or get close enough to magnets, the objects become magnets. Pull the nail away from the magnet. Does the paperclip still cling to the nail? Rub a steel spoon along a magnet. You can feel the spoon being pulled toward the magnet's ends. These ends are called poles. A magnet's power is strongest at its 2 ends. One end is called the North Pole. The other is the South Pole. Fun fact, if you break a magnet apart, you have 2 new magnets. Each separate piece has its own North and South poles. The poles of a magnet can push as we pull. Poles that are alike repel each other. The North Pole of one magnet will push away from the North Pole of another. Fun fact, in Japan, some high-speed trains use extra strong magnets. Magnets on the train repel or push against the magnets on the track. The train seems to glide on a cushion of air. Opposite poles attract one another. One magnet's North Pole will stick to the South Pole of another magnet. Magnetic Earth. Earth is a giant magnet. It has 2 ends or poles just like magnets. Earth's magnetic ends are close to the North and South poles that are shown on a globe or a map. The cold North Pole and South Pole are covered with ice. They are not the same as the Earth's 2 magnetic poles, so they're totally different. How does a compass work? Earth's magnetic power pulls other magnets. The needle on a compass is a tiny magnet. The needle always lines up in the north-south direction, pointing toward the magnetic poles of the Earth. Fun fact, a compass won't work if you are standing too close to the cold North Pole. The needle points to the Earth's magnetic pole. Once you travel past that magnetic pole, the needle does not point northward anymore. A compass shows us what direction we are moving in, north, south, east, or west. Sailors once used compasses to cross the ocean and find their way back home. Magnets all around. Some of Earth's rocks have magnetic powers. Long ago, the Greek and Chinese people discovered the rock magnetite. The Greeks were amazed as they watched magnetite pull small pieces of iron. The ancient Chinese hung splinters of magnetite from strings and watched the rocks line up in a north-south direction. Fun fact, another name for a piece of magnetite is lodestone. Lodestone were used to make the world's first compasses. Today, electric fans whirl, refrigerators hum, and burglar alarms ring with the help of magnets in their motors. Huge magnets help junkyard workers lift tons of scrap metal. These magnets move cars and trucks as if they were just small toys. Doctors also use magnets in special machines to look deep inside your body. Magnets push and pull us all around the world. Alright, that was pretty fun. And it gave a list of experiments, which I think are kind of cool too. So I'm going to show you these so you can pause them at home if you want to check out the experiments. Okay, here's one. Set. It's kind of got a glare on it. There we go. Here's another set. Kind of got a little bit of a glare. Not too bad. Alright, and then, okay, to kind of wrap that read aloud up and a little bit about magnets, the 3 things I want you guys to remember is attracting, okay, the word attracting. Magnets attract other magnets and some metals, okay, especially if it has iron or steel in it. Repelling, what repel means, that means magnets repel each other, right? Magnets repel other magnets, okay, push away. And then working at a distance. Magnets don't have to be touching to push or pull on each other. It has a force that exists that you just can't see. So good job, guys, listening to our read aloud. I hope you enjoyed that and learned a little bit more about magnets and how magnets interact in our world. When you're finished watching this video, I want you to click the attached Google form and answer a couple questions about magnetic characteristics. You may want to start with the words 2 characteristics of magnets are, but it's whatever you want to do. Be sure to click mark as done when you finish all parts of this lesson. Well, guys, that's all there is to it. I hope you have a good time, and I can't wait to see you again.